Okay, I think we need to move on. I'm just quite conscious of time. So we have our next speaker today, but I'd like to introduce the next speaker. Again, some words of appreciation for Tony Ryan. Tony, I'm sure you'll be looking at the chat books. So let me welcome our last speaker, which is a keynote speech from Adelaide. So Adelaide, are you online with us? Adelaide, just want to confirm. It's nice to see you again. Very familiar faces. I know it's been a long day for you, but thank you so much for this presentation. So let me introduce you to the audience. So Adelaide, she's the project manager in the European Federation of Welding, Joining and Cutting, or EWF, which is a very big organization. And since 2016, she's been responsible for several education projects focused on the development of educational programs and new professional profiles for the manufacturing industry at a European level. Her field of expertise include the development and implementation of projects aimed at developing national and international standards for vocational education and training, or we call VET, and its alignment with European policies and tools such as the Learning Outcomes Approach, or LOs, Vocational Credit System, or ECVET, and the European Qualifications Framework, EQF, within the EWF qualification system. Adelaide holds a master's degree, MSc, or Master of Science in Educational Sciences since 2008 for the University of Cumbria. So thank you very much for your time today. And if you'd like to share your screen, very
Thank
much
you very
appreciate
much.
that.
Thank you very
Thank
much,
you.
Eugene. I hope you can hear me well. Good afternoon
Perfect.
to all participants. It has been a long day and a quite interesting event. Thank you again for the invitation. I see now that my presentation is loading, so it should appear in your screens in a couple of seconds.
It's not yet appearing actually, to be honest, but not to worry, I've got it back up.
It's loading. I think.
Yes, it's loading now. It's perfect. It's loading. Okay,
Perfect.
thank you.
So thank you also for introducing me, Eugene. As Eugene mentioned, I'm a project manager at the European Federation for Welding, Joining and Cutting. And today I will share with you our experience at EWF in developing an additive manufacturing qualification system that is addressing not only the current skills and workforce skills development, but also we aim to reach already the future skills and the qualifications of tomorrow. Very briefly, I will introduce, for those who are not familiar yet with the International Additive Manufacturing Qualification System. So in a very short presentation, the major characteristics of this system, and also introduce to the qualifications that we have already been implementing to the system. And then in more detail share with you our achievements in the sector skill strategy project, the SAM project, and the major findings that we have reached with our market studies conducted so far. Starting by the International Additive Manufacturing Qualification System, it was launched by EWF in 2018 as a natural consequence of the growth of the additive manufacturing technology, and also facing the industry requirements to have well-defined occupation and skills for the personnel leverage with the technology. So EWF has taken our experience. We have taken our experience also in the welding sector in developing a qualification and certification system for the workforce at European level. So we are dealing with a unique system that in Europe and also outside Europe is ensuring that workers are trained with the exact same quality standards independently of the country or the region they are attending a course. And the uniqueness of the system relies on the fact that we are aligning the development of the training programs with also the industrial requirement. And so our best practice in connecting industry requirements with educational programs has been brought within the additive manufacturing qualification system. Our approach in terms of the delivery of qualification and also development of qualifications is characterized by being a systematic and collaborative approach. It means that we are collaborating and making sure that both technology experts and also pedagogical experts are working together in the agreement on the content of the the training programs for technical areas. So the development process of the qualifications has this spirit and has this alignment also with industry requirements embedded, and we are delivering for the different levels of qualifications, different qualifications with different levels according, so it's range from the operators to the engineers, supervisors. So the idea is not to concentrate on a specific program, but to reach and to encompass the full value chain, and thus covering both vocational education and training and also higher education. The outcome of this development process has led us to define the professional profiles, the occupation that you can see in the screen. So currently, the international qualification system is composed by occupation that range from the operator to the metal AM coordinator, which encompasses engineer qualifications, designer qualifications, and also supervisor qualifications. These profiles were developed specifically for metal IM, but we are still working, and the idea is to continue developing the system so that it can also aim to develop new profiles for instance, for polymers, ceramics, and other materials as we define them to be a need of the industry. It's also important to mention that we foresee specialization within the system. It means, for instance, for the operators, for the engineers, and also for the design, we have different profiles that were defined according to the different technology and to the different processes. And so it's possible for these experts to be specialized on a specific process. In terms of design, currently there are 2 profiles being already implemented, but yet, as you will see later on, we are already developing and conducting pilot courses for a designer for polymers. As we are dealing with a fast evolving technology that requires the development of different level of knowledge and skills, we grounded the qualification system in a modular system. It means that the qualifications are designed and structured in small units that can be trained, that can be thought and assessed in an independent way. So the students only attend the modules that are of their interest, or the ones that they feel to have less knowledge about. Of course, when attending more and more modules, the student can progress within the system and can also achieve higher levels of qualification. So the system has the added value of being tailor-made, flexible, and also enabling this progression. Coming to the Sector Skill Strategy project, the SAM project plays a key role in establishing the international IAM qualification system. The project is an educational project. It's a blueprint that aims to define a strategy and to establish a strategy that will ensure the growth of the additive manufacturing sector in Europe for the next 10 years. So in terms of objectives of the project, we are dealing with establishing a structure that will analyze and identify the current and future needs of the sector concerning additive manufacturing, and also guarantee the implementation of the trainings, in this case of the International Additive Manufacturing Qualification System, through a network of training centers. And one of the core outcomes of the project is the establishment of an European observatory. That is the structure that congregates all these activities. So as you can see in the flow chart, we have here the expected results of the project. So we are aiming to establish specific methodologies for the forecast of the skills, also specific methodology that will enable us to constantly revise the existing qualifications that are addressed by the AM qualification system, and revise them, create new ones. Apart from that, we are concerned in preparing the future generation regarding additive manufacturing. So here the focus is also to provide information, to bring additive manufacturing concepts to children, to youngsters, and try here to raise their interest within this technological area. And so the spirit is also to have, and the project has this added value of not only looking into developing high-level skills, but also to have this more broad education mission. In terms of consortium, we are 17 partners in the project from 9 European countries, which represent both education and industry fields. The idea is to have here a balance of expertise so that we can really address the gap between what is the industry demand and what is the educational offer. Apart from these partners, and also to mention that from the UK, we have 3 organizations. We have the University of Brunel, we have MTC, and also ANSYS that is working in the consortium, and also SNANT that Alan was today with us. So there are universities that are in the consortium. And apart from these organizations, we are also counting with the support of external organizations. So we have over 30 associated partners working with us, and more than 60 experts that in a direct or indirect manner are supporting the project. It's as we see that it's quite challenging mission for the next 10 years. We need really to think in a collaborative way and to work together to address the challenges of additive manufacturing. With this spirit, and as I mentioned, one of the core expected results is the establishment of this European Observatory. It's one of the core activities. The Observatory, in terms of structure, is composed by 2 councils. We have a Qualification Council and an Industrial Council. The idea is to reinforce the collaboration between the 2 worlds and bring them to work together. We have leading experts for taking care of the council. So we have for the Qualification Council, David Wimpenny from MTC, which is leading the Metal AM working group. And we have Paolo Capo from Idonial that is responsible for the polymers AM working group. So the Qualification Council has the mission of reviewing qualifications. So it means developing training programs and also revising training programs for AM. And we have a consultative body, which is the Industrial Advisory Group, which is led by Martin Schäfer, that is responsible for providing insights about the technological trends, future developments. In terms of composition of this industrial council, we have mostly research organizations and also AM suppliers, technology providers composing this group. And it's through this activity of the observatory councils that we are guaranteeing that the system is kept updated, the qualification system is kept updated, and that we are able to have a training network delivering in Europe and outside Europe the training foreseen in the system. Another important mission of the observatory is the continuous skills forecast. So it means that we are continuously in an annually basis, we are doing the assessment of the current needs of additive manufacturing, but we are also looking into a short-term scenario, and we are able to identify what are the major needs that the industry is identifying. And another scenario is the 10 years. It's a long-term scenario, so it addresses the next 10 years. So we have these three scenarios that we are working on. We are using, for each one of these scenarios, we are conducting market studies with different target groups, and the aim is to really have then to compare the results and to fine-tune the training programs that we are delivering. The tools that are used in the forecast strategy, in terms of methods, we are mostly using surveys to conduct these studies, also complemented with interviews when needed, some desk research and literature review, and also we are using explanatory methods like brainstorm sessions, workshops that enable us then to define the priorities and identify the needs. Today, I will share with you the results that we have achieved for the foresight scenarios. So for the next 10 years, what are the trends and major developments that we expect to happen? Of course, it's expectations, and we need then to fine-tune our capability to predict the future. But we were able to come to some findings that we will then share with you, and to see how these findings can impact the development of new qualifications, or to review existing qualification and occupations. Very shortly, because we are quite we have quite long days. I will not extend much regarding the results that we have achieved in the first year of the project. We have every year we release a report, and the report about the findings of the skills needs validation in 2019 is available in our website. So it addresses in this first year we performed surveys with industrial organization. We had several surveys to the companies. We also had research organizations auscultation, and we also talked with recruitment agencies to identify what are the major occupations and the current needs of the market. Again, in 2020, we used the same approach. This time we concentrated just on the short-term needs, and we talked with workers to be able to identify also to be able to characterize the profile of an additive manufacturing worker and to understand the concrete needs of these workers. A total of 138 workers were participated in this study. It was interesting to see and to identify what are the current knowledge and skills about the different materials, the different process, and also to understand a little bit more about their training experience. Just for curiosity, we identified that 60% of the people that were working and that participated in this study were working for with AM technology from 1 to 5 years, most of them, and that 50% had not participated in any formal training. So the majority of the experience and the knowledge that they gained regarding the technology was in the context of the company, so in the job training. We were also able to identify technological what are the most required technological skills and the ones that the workers identify as lacking in terms of development, and also to identify more transversal skills linked to entrepreneurship, to digital and green skills. And we were able also to compare what are the perception of these workers in terms of the evolution of these required skills. As I mentioned, we also conducted a study with recruitment agencies, and this was performed this year. We had a low number of recruitment agencies collaborating in the study, and so this is not representative. Although our intention with this survey was to characterize what are currently the job and hiring demand per occupation. We identify, for instance, that for link with metal additive manufacturing occupations, the most required hiring offers are related to metal process engineers, materials engineers, also with designer and operators or technicians. When comparing these results with the polymers needs and the same profiles but applied to polymers, we see a slight decrease on the demand, which concerns the materials engineer and the operators and technicians occupations. Then we try to find out if there has been an increasing number of job offers in the last 2 years, which was confirmed by the recruitment agencies, and they identify that, and the majority of them identified that this growth of demand is around 21 to 30% in the past 2 years, so since 2019. Currently, we are conducting our annual study on additive manufacturing training practices, which I invite you to participate as well. This study aims to characterize the current additive manufacturing training practices, to understand what kind of students is attending these courses, which kind of approaches are used in the training for additive manufacturing, among other results. So this study, this survey will be available until the end of this month, and we expect to have the results in the fall. This study are very important for us to be able to progress with the SAM project and to be able to define the content of the trainings that are being developed in the scope of the project. Currently, and as I mentioned before, we have already developed a new profile, which is the AM Polymer Designer profile, which is composed by a set of competence units ranging from design property, materials properties, design principles, and also design for specific process like material extrusion, also for powder bed fusion. And we have developed 2 cross-sectorial competence units, so trainings, which is the business for additive manufacturing, and also a module for certification, qualification, and standardization. Finally, the trends and the results that we have been achieving in terms of foresight. So, as I mentioned, we were conducting this study to predict the additive manufacturing developments and trends in the next 10 years. In terms of approach, the approach that we use in this study is based on the Delphi method, so it's composed by 4 stages. The first stage concerns the development of a workshop. The idea here is to bring together a limited number of experts that are invited to brainstorm about the specific developments for AM, also to reflect about the future occupation and the skills that will be required until 2030. After this first workshop, the first survey was prepared with the major conclusion from the working session, where then we invited again the experts to identify the priorities of the major conclusions that they identify in the workshop. And then after a first round of survey, the outcomes, the results were analyzed, and the second survey was developed to fine-tune and to come out to conclusions. And today, the last stage and fourth stage is the presentation of these results. In terms, and the first aspect that we studied was in this foresight workshop was to understand what will be the future AM applications and what are the major trends within these applications. We find out that in terms of application, the metals will continue to be predominant. So we will have mostly applied AM applied to metals. In terms of materials, the most required one and expected to be the most required ones are linked to aluminium, titanium, followed by copper and inconel. And in terms of process, the most required process are expected to be the powder bed fusion, and also bioprinting process and biodetecting. In terms of sectors that are expected to be most influenced by additive manufacturing in 10 years, the aerospace sector is in the front of these sectors, followed by the medical sector and also the automotive. So I think here there is no novelties when compared to what happens nowadays already. Then some examples of the what will be the most expected parts that will be produced for each one of the sectors. For instance, for the medical, the implants and prosthetic was mentioned as most to continue to be the most produced parts. In the aerospace, the fuse nozzles and systems, and also the turbine blades. And for the automotive, the spare parts and low volume interior parts. Then another finding was in terms of expected developments and technological trends. We were able to come out with a list of top 5 developments related to additive manufacturing technology. So these relate to the fact that additive manufacturing is expected to be established on a more serial production, that more public standards will be available for different areas, and also more accurate simulation available for most the technologies, new materials appearing, and also there is expected that there will be a reduction of costs. In the second round, we try to find out more about these concrete aspects. And for instance, in terms of development of standards, we identified that the areas where this development of standards is expected to be happening is related to the processes, to the materials, design and modeling. In terms of reduction of costs, they are related to a reduction within the acquisition of machine and equipment, and also to the materials and feedstock. One of the major, at least here we can see that there is a predominant impact of these trends in the labor market, and it is linked with the reskilling of personnel. An average of 78 experts identify that these trends will impact on the existing occupations. And also, they identify that more digital experts will appear and will require to be trained regarding AM in the next 10 years. Looking into the profiles and from the worker, the personnel that is leading with conventional process, we identify that all the welding personnel, for instance, will need to be trained within additive manufacturing. So the welding inspectors, the welding coordinators, and the welding operators. In terms of the digital experts that will require to be trained regarding AM, the majority of the experts identified as specialists for process and algorithms, data managers, and cybersecurity experts. Finally, the predicted occupations related to AM that will be available into 10 years. So we see here that we will continue needing process experts and also additive manufacturing designers. So all these findings are of extreme importance for us because, first of all, because it's an important indicator that will enable us to fine-tune and revise the sector skills strategy that we have defined within the project. The strategy has been defined last year. We identified 7 gap drivers, and for each one of the gap drivers, we identified concrete activities to be conducted through the SAM project and also beyond the SAM project until 2030. And so being able to conduct these studies help us to fine-tune the strategy and to have a more realistic approach to what we are doing for the development of skills for additive manufacturing. It will also enable us to predict future trends and skills needs. These studies enable us to anticipate and to better plan the training programs for the personnel working in AM, either through upskilling or reskilling of these workers. It's also a better way to guarantee an alignment between the demand from the company side and what is offered by the training centers. And it will ultimately influence also and support the decision makers in terms of policy reform and also to influence the future funding programs in this case released by the European Commission, and to better address the awareness of the future generation regarding additive manufacturing. So to conclude, we invite you to collaborate with us. So if you are a potential training center, you are already. So we have with us, well-experienced universities doing excellent working activities and training for AM. So if you'd like to collaborate within a larger network that you have already, feel free to contact us. We are, or even if you would like either to implement training and delivering the qualification foreseen in the system, or taking part of the councils of the Observatory and working with us in the review of the training programs and creation of new training programs. So we are willing to collaborate, and we are pleased to count with your support to guarantee the development of AM for the next 10 years. Thank you very much for your attention, and I'm available in case you have any question that you'd like to address.
Thank you very much, Adelaide, for your presentation. It's again very informative. I know it's been a long day for you, and hopefully there won't be too many questions, but I do have a few questions for you as well. But let me see in the chat box whether we have any questions. Just feel free to use the chat box to ask questions. Doesn't not necessarily need to be about IAM QS, but it could be about AWF, or it could be about the wider scope about qualifications and training as well. So just feel free to use the chat box. I think there are some mentions of appreciation from Patrick Pradell. Say thank you very much for this very interesting presentation about skills requirements in AM. Okay, we'll give some time for people to ask questions, but I do have one question for you. So my question really is, we understand that there is a forecast about skills specific to additive manufacturing, but what do you think about the convergence of different skills coming together? So for example, in one of the presentations from David Wilson, he mentioned about the question coming from many other participants about 3D prints and electronics. So you have 2 different very big disciplines. electronics and additive manufacturing, do you see this making the qualification system even much more challenging, because now you need to have two different sets of qualifications specific to electronics and also specific for manufacturing, and then also to the process and the materials, and eventually you will see more and more complications, the convergence of different disciplines coming together. What's your view on that, Adelaide?
Definitely, that this convergence is expected, and we try to within, not in this, although we are able to identify some of the trends in the next 10 years, what we are doing is that every 3 years we are able to identify the major trends and how AM can relate to other technology and also to other innovations that are happening. So the challenge for us is to capture all what is happening in additive manufacturing, and for that we need the inputs of the experts that are dealing with, and mostly of the research organizations, the universities that are working within the development of the technology and looking into these synergies. And for us, it's important that they can participate in our study and that they can take part of the council's working groups and also the advisory group, so that we can capture all this information and to deliver training programs in alignment with what is the natural development of the technology.
Thank you very much.
It's quite a challenge. Yeah.
Yeah, it's a great challenging, I think, in the future, and that's why I think you probably need the support of, say, associated partners or members, as well as different countries reporting what's happening nationally, locally, and regionally. So this is again a challenge, a long-term challenge for people interested in this area. Thank you. We've got a question from this guy, Venkatesh. Dayalan, Venkatesh, you've got a question, I understand. Would you like to either type out in the chat box or feel free to use a microphone? We can't hear you, Venkatesh. Go ahead.
Can you hear me, Dr. Eugene?
Yes.
Yeah. So my question is, may I know how aggressive are the organizations who are investing in additive manufacturing technology to put the technology which is being used to produce prototypes rather than in mass manufacturing? So how are companies coming forward to produce mass manufactured units in terms of volume? Like as you mentioned, for the next 10 years, you are looking at the growth rate in automotive sector or the aerospace sector growing in a much faster pace than other sectors. So can I have some insights about that?
So I'm not sure that I understood your question, but what I can say about the collaboration with other sectors, we foresee in the strategy, still we have not within the project had the opportunity to develop it. But what our intention is within the Industrial Council to have representatives of this sector. So from the automotive, from the aerospace, and also from the naval sector. So that we can collaborate with them in the sense of identifying specific sectorial needs, and that we can translate this into the proper training programs. We have currently, because also the automotive sector is conducting a blueprint, which is actually foreseen to end this year. It's the DRIVES project. So we are in collaboration with the DRIVES project, and we are currently establishing an AM working group within their network, so that we can better address the interests of the automotive sector, and we still to better fine tune and to be more concrete about what are the real needs of these workers in terms of upskilling and reskilling.
Thank you very much for the time. Thank you.
You're welcome. Thank you.
Thank you. I'm just looking again in the chat box. If there are any other questions in the chat box. I think there are no questions at the moment, which I think is fantastic because it means that people understand your presentation. It's very comprehensive in a way that I think in terms of time to come, this qualification system will be established and recognized, and hopefully not just within Europe, but also at a wider scale, maybe at international level. Because I think you did mention to be associate partners, it can be international associate partners as well.
Exactly. So any organization outside Europe can collaborate with us. Yes.
As ATB, as an associate partner.
Yes. So since we are running the project, we invite the organizations to support the project, and for that they can become associated partners. It means that it's just to really clarify and identify what will be their concrete contribution to the project. And then as all the results, the International Additive Qualification System and the Observatory will be kept after the project. So we will keep collaborating with these organizations, and they will be members of they can be members of the councils, and they can also be part of the training center network and deliver the courses and the training programs that we foresee in the International Qualification System.
Thank you very much. Thank you. I think I don't want to take up too much of your time, and very appreciative for your presentation. But it's been fantastic. If you'd like to maybe leave your contact details in the chat box, if people would like to be partners, we help them to get in touch with you. Thank you very much for this afternoon's presentation. It's a pleasure. Thank you. Appreciate that.
Thank you. Thank you.